Good morning, seventh graders. It's so good to see you today on this fine Monday. We've got we've got 3 more lessons to do this week, primarily around factoring and solving quadratic equations. So let's take a look today at factoring trinomials, where the first term is not just 1x squared or 1a squared, but has a coefficient there that is greater than 1. Okay, so let's take a look at that. We're specifically going to look at examples today where one of the two end numbers, either the leading coefficient at the very beginning or the end number, which is the constant, the plain old number, is prime. Okay, so let's take a look at that if they are prime. So I've got 4 examples on the board. Let's start on the right here. All right, so I'm going to start on the right. Hopefully I won't cause too much shade on the board here with the lighting. Let's see. I've got a 2x squared leading this trinomial. I know, well, let's look for a greatest common factor first. 2, 15, and 18, I don't see one. I'm always going to check for a greatest common factor first. I don't see one here. And I know that if this is factorable, then it factors down to 2 sets of parentheses with binomials in them, right? So, and I know that there really is only one possibility of what goes in these first positions to make 2x squared, 2x and x. And it's fine if you put x first and 2x second, that's totally fine. But what is just clear is that there's nothing else that can go here that says 2x times x is 2x squared, because that is prime. So now what we get to do is we get to look for factors of 18 that will FOIL and give us 15x in the middle. So let's see. Let's do 2 and 9. So I'm just going to kind of think here, what if I put a 2 here and a 9 here? Well, I'm not sure that that's going to work very well, because 2 times 9 is 18, plus 2 more is going to give me, 20. So that doesn't work. So 2 and 9 didn't work. How about 3 and 6? That looks promising. If I put a 6 here and a 3 here, then this is going to be 2 times 6 is 12, plus 3 times, or 2x times 6, is 12, plus 3 times x is 3x. So if I put pluses here, then this works. 2x times x is 2x squared. 12x plus 3x is 15x. 3 times x is 18. You see that? Great, let's take a look at this one. So I'm looking down here, and I'm going to do, I notice that 3x squared has a prime coefficient, so I can go ahead and just put in 3x and x. All right. Whoops, sorry about that. Now I'm looking at factors of negative 18. One of them needs to be positive, one of them needs to be negative. So I'm going to go ahead and say, let's see, if I did 3 and 6, so let's see, if I put a 6 here and a 3 here, well, I don't know, I've got 18 and 3, and if I go subtracting those, that doesn't get me close to this 3 in the middle. So I'm going to get rid of that. And let's see, how about if I put my 6 here and my 3 here? Well, oh, look what I forgot to do. I forgot to pull out a greatest common factor, didn't I? Oh my gosh, I guess we'll have to do it at the end. Well, let's check this. 3x times 3 is 9. 6 times x is 6x. 9 minus 6 gives me 3. So let's see, I need it to be negative 3, so I'm going to make the 9 negative and the 6 positive. All right, and let's see, I think that works. 3x times x is 3x squared. Negative 9x plus positive 6x is negative 3x, and 6 times negative 3 is negative 18. But I'm going to go ahead and take a look at these right here, and I'm going to notice, hopefully you'll notice, that there is a greatest common factor in this binomial, and I see it as a 3. So I'm going to go ahead and pull that 3 out front. This is x plus 2 and x minus 3. And this right down here is my final factored form. Okay, so let's see. I'm going to come on this side now. I've got one more. In this case, my first number is not prime, but my last number is prime. So I'm going to look for greatest common factor, which I forgot last time. 6, 17, and 5. No GCF. Let's open up some nice big parentheses. And instead of putting the first terms in place, I'm going to put the last terms in place. I know that this has to be 5y times y to make 5y squared. And that's the only option. So let's see here. I need factors of 6 that are going to give me negative 17 in the middle. I'm thinking that I probably need to multiply 5 by 2, but maybe by probably by 3. Like I probably need to do 5 times 3 gives me 15 because this 2x. So let's see here. So I thought about it as 2x times 3x equals 6x squared. And now I'm going to have 2xy and 15xy together give me that 17. And I know now that a negative times a negative gives me a positive, and a negative plus a negative gives me that negative in the middle. So this works. We can check it. 2x times 3x is 6x squared. Negative 2y and negative 15x give me negative 17x. And negative 5y times negative y gives me 5y squared. Awesome. One more. Okay. I'm going to put this 3y and y in place. Let's make that look better. I've got 21x squared here, so I need factors of 21 that are going to work with this. Let's see, I've got like 7 and 3 might work. I'm seeing a 7 and a 3. And I need an x and an x. So let's see. This is going to give me 9, and this is going to give me 7. And I need this to be negative, so I'm going to make negative 9, positive 7. Let's test it. 7x times 3x is 21x squared. Positive 7y and negative 9y, are xy, excuse me, are negative 2xy. And 3y times y, negative 3y times positive y is negative 3y squared. So this is factoring trinomials where the leading coefficient is not 1, okay? And where the numbers are prime. Excuse me, at least one of the two leading or end coefficients or constants are prime. So you can just put that in place, figure out the rest, okay? Have a wonderful Monday.